again, you know, I use the specific environment, and it's all the same concept, but it's just a little bit different. Like permissions are a little bit different. Using a different client might behave differently, and so on. Okay, SSH tunneling is a whole other beast. I'm gonna do a diagram, which is gonna be super ugly, but I hope will make my point across. I'm looking for something that can draw. Okay. So our the system we are connecting to is on the internet. This is our client over here. There's probably better tools that I could use. And let's read the description of our challenge from the pivot box machine. So what machine are they talking about? Oh, we acquired it in the SSH challenge. So we are reusing something we got access to previously. You can reach a service that spits out a secret. However, pivot box lacks many tools like NC or SOCAT. Maybe we should learn to use SSH tunnels to reach that service. The service is at sysadmin-service on port 5555. So if we would diagram this, it basically would look like this. So our sysadmin service, let's call it SS, is behind a wall, right? It's not reachable directly from our laptop. So there's no way to do this. So that doesn't work. That doesn't work. Now, and apparently from SSH, we don't have the tools necessary to be able to poke directly the service. Let's try. You know, you never should take the hint for granted or the description for granted. Let's try. Okay. Usually for a plain text service, you use netcat or curl or whatever. We can try that, or we can try ping sysadmin service. So now we will not. Oh, I don't even have ping on the system. Can I install ping? Oh, I don't have permission to install software. So I could maybe upload software. That could be a way to solve that challenge. But clearly in my description, this is not what I want you to learn here. So we're not gonna do that. But then I can try, okay, do I have curl? I don't have curl. So curl is a HTTP client. Do I have netcat? I don't have netcat. Do I have wget? I have wget. So maybe this could work. But again, you know, the goal of the challenge, let's try. Ça marche? Non? Non. Hein? D'habitude, il est dans le host file. OK, on va aller regarder. Okay, it works now. So the service was down, but I brought it up. So if it was down, it means that it's easy, it's fragile. So let's be kind with the service. But if it's ever down again, just let me know. We'll restart it. So it worked-ish, but I couldn't write the file, so permission denied. So clearly, again, this is not the way. But basically, what I want to add here is that even though we have presence here, we cannot try to reach the service this way. So that does not work. Here, we don't have sufficient access. But so this is where tunneling or pivoting kicks in. We can use SSH as a tunnel. Okay, so this basically is a tunnel to reach the other system on the other side of it. So the connecting to SSH regularly, we build the tunnel and we tell the tunnel when a packet arrives here, we want you to send it there on the other end of that tunnel. So we're gonna write an SSH, a fancy SSH command that will do that. It will go in the tunnel, it will go out the tunnel. So this is where it has reach to the other network. And well, this is getting confusing, but and it will like come out and be able to reach the other system. Now, in SSH's language, this is called SSH tunneling, but specifically local port forwarding. So now we can, Google it, and just, we don't care about the concept. We want the command. Okay, the command is here. I explained the concept. That's why I'm skipping ahead. But so -L, local IP, but it's optional. Local port mandatory, destination and destination port. Luckily, we have all that in our challenge description. So we disconnect. This is important. We're tunneling through that system. So we're not gonna do that on that system. So we disconnect. We reuse our previous command because we need to authenticate to the service with the same user and the same port and the same key. But we're gonna add the forwarding characteristics. So destination port, if we look at the challenge description, is 5555. So we have it. Like the service that we're trying to have spit out a secret is running at 5555. So let's do that. 5555. The destination is the name. So here we Docker is kind with us. It provides DNS. So we're not using raw IPs. We're using names. So we put that in here. And then a local port is pretty much at our discretion. I like to use 1, 2, 3, 4, 5. Easy to remember. And then the local IP is if you need to bind to something else than localhost, but we don't need to do that. So I have SSH 2 times here, so I need to remove the extra one. Okay, so now we are doing SSH. We're specifying that we want to do a local forward. So we're building the tunnel from our machine to the pivot box system on CTF 101. Which means that the end of the tunnel will be on the other side of that system. And here we're saying the other side of the tunnel or the system should reach to sysadmin -service on port 5555. So going back to the diagram, the command is building this. Let's use another color. The command is building this portion here with the specific intention of sending to that system. Now, another thing that people might be surprised when they run a command like that is that we will still get our prompt. We are still connected on pivot box, and this is why the reason is SSH has channels, and we still requested a command channel, but we added the tunneling channel on top of the command channel by default. We could add a flag that will not require a command channel, but it's just not necessary. But what's counterintuitive about what we just did is that the next step needs to happen on my local system, not on the pivot box system. So I need to open a new terminal. In my case, I'm going to split my screen so that you see. And but so the next command is I want to send that packet, right? I want to reach the end game here on port 5555. So to do so, I'm gonna use netcat. Now the tunnel is from my machine to this service. So I use 127.0.0.1 or localhost, and I chose to use port 1235 45, sorry, 12345. And so now what will happen if I do that? Congratulations, I pivoted. So my local packets were sent to the destination that we specified in the SSH tunnel. That service is just a kind person that gives the flag on first hit. But then, you know, in the real CTF, the twist is that you'll have to exploit that service or do something more to that service. But the pivoting concepts remain, and they are really important. So we're gonna copy this, put that here, submit, and we won. Good. Now, could have we done this directly via the machine? Did you guys figure out from PivotBox? How did you do it? Standard out. Okay, that's a cool one. So let's do that. So I was asking because I knew they would bypass the restriction of the challenge. So let's just do that for fun, right? So sysadmin service, and then since this is a URL, now the port is not a different parameter. It's part of the URL. And since HTTP is a text-based protocol and my flag is text, it's gonna work. It's gonna spit it out. But now the previous error we got is it tried to write to the file system, but the file system is unwritable by definition. I didn't want you to copy executables. So what Vincent suggested as a workaround is, okay, but wget, you can tell it to, instead of write a file, to show the file, show the content. So this is capital O for output. And then this would by default try to write to a file, but we can't. So we're gonna use dash. Dash is like Linux lingo or Linux standard of saying it's standard out. So the console. So with this, capital O. Okay. So with this, what we have is, you know, you see that it tried to do HTTP. You see that there's something wrong because it's no headers and it's assuming a super old version of HTTP. But still, you know, we got somewhat mingled. We still got enough of the flag to be able to win the challenge. So this would be a bypass of the challenge. And it's totally legit in CTFs, right? We try to put restriction, we try to send you in a direction, but you can do whatever you want. There's no problem. Okay, so moving on. So now we're really shifting categories of challenge here. But these are the web challenges. They're fairly approachable and interesting. But the sysadmin is kind of the base layer, you know, necessary for more infrastructure or you know, type CTFs. So the source. So here the challenge says use the source. Luke said 1,000 challenge designers before me, and there's a website. So we're gonna open the website, take a look. There's a username and password. I'm not sure what to do, but I'll take the hint and do a view source. On peut-tu fermer le rideau? Tu veux me chercher une bière? Pour le monde sur stream. L'IP, s'il te plaît. Okay, so what we have here is in the source, so we did view source. We have to do disable the support account. And then the support account, if needed, support account is with a username and password. So basically, this is HTML code to say, you know, it's a comment, don't display it. I saw, so this is pretty much in our face, right? We know, like, we need to, you know, copy this in the page. We're going to do this in just a second, but before I go there, I want to talk to you about a twist on a challenge like that I've seen, and just to put you in the mindset of CTF solving. But I've seen a challenge like this, that there were empty lines at the bottom, and the real flag was just 12,000 lines below. So the only thing that was different is that there was a scroll bar on the side. So sometimes it's really in your face, right? You need to think about it, or you need to do a Control F and then search for flag or whatever. Now the username and password, so it's welcome to. We can close that. So support, welcome to, and login. Hidden account activated. Here is your flag. So we got this. Paste that here. Here we go. Yay. SQL. So things are getting spicier, but I see many solved, so that's good. Okay. SQL injection is. Ouais, faudrait que je clear mon Chrome. So if you're a programmer, this is kind of obvious, but if you're not, this is more difficult. But so why is SQL injection so pervasive? It's because data is mixed with code together, thrown into an interpreter that is the SQL engine. And when that is done, you know, there's all sorts of bypasses to be able to access that information. So if so this challenge is instructive, and it is a one-on-one challenge because it shows you that code. So what's happening is SQL is structured query language, and it's to ask questions to a database. And you c'est un quoi? Redondant. Comme ça, t'as pas besoin de te relever. So usually all SQL queries return a user, not a user, columns and values. Okay, so rows and columns. It's a table basically in most queries, and we see that query here. So this is not a regular thing, right? This is special purpose made. But you can also think that whenever you're trying, you think you have a real SQL injection, you can always spin up a little database on using MySQL or SQLite and try the things on your system where you can see where you're not in a blind environment. So there's always ways to reproduce a smaller subset of the problem on your computer. But now we have the output. So I put in OR because the classic is like OR 1 = 1. And here we have hints. So what we are seeing here is it is in the database. Okay. So we are having, this is the content of the database. So I'm going to search for flag. Why not? And flag is, oh, nice try. So my database is basically trolling us. So now I'm going to try to spice things up by like, oh, I'm going to try OR 1 = 1. And it says you are onto something. But let's take a look at our string. And the mistake here is that, so we are in a like context. So this is the condition of the query, and there are double quotes. So when we put in OR 1 = 1, we never escape the context of the double quote. So let me, whoops, not that here. Let's disconnect. Okay, so we have this here. So what we want to do, so this is the output of when we write OR 1 = 1. Okay, but what we want to do is close that double bracket. So this will give something like this. So like that, and then oops, and then we're gonna have this. Okay, so if we put only a double quote, this is what's gonna happen, and this is probably not legal SQL. Let's try. If I put just in double quote, There are so many ways to bypass that challenge, by the way. Okay, so I have an error. So it means that basically the query failed and MySQL threw an error, PHP caught the error, and PHP threw the error back at our face. In many production contexts, the error will be hidden. So all you'll have a 500 or whatever, and this will not help you. So okay, so this one is broken. Now, how could I unbreak it? So this would kind of be jumping straight into the solution, but let's try. Okay, so I'm gonna do double quote space or then 1 equal 1, which means that the query will become this double quote or 1 equal 1, and then the remaining percent and quotes will still be there, right? So do we think this will work? Let's try. Since you seem unsure. We have an error. Why is that? Because the double quote is still here at the end, and it's never starting, never ending. So it's an unbalanced double quote. So what the trick of all the SQL injection folks is to there is a functionality in SQL where you say the rest of the line is a comment. So if you turn the rest of the line as a comment, this means that our code will look like this, and then comment, and the rest doesn't matter. No more quotes balancing or whatever. We can try that. Oops. Boom, we've got our flag right here. And so the value was flag, but written with fancy Unicode letters. And we have a flag with our flag. Now, let's think of a couple bypasses, because now we did kind of the 101 SQL injection. But looking at it this way here, I was like, we're almost there, right? And this is a new bypass that I figured now, because there's another one that is even easier that I'm keeping for later. But so double quote, and then all I need to do is comment the rest, right? That would work. So let's try if it does. So we're basically, because the percent is like the asterisk of SQL. Percent means anything. So if we only have like percent, we will get all the database or all that table. Sorry, need to be specific. So let's try with just the close quote and then dash dash. It works. We still have our content. Now, the easiest bypass is the percent bypass, because you will basically get in the command triple percent, which means everything. So let's try, and it works. So this challenge is completely, broken if you think about it from the SQL perspective, but it's still educative about how it works, and the fact that you can see the query really helps you there. In a CTF 201, we could do the step of having your own database locally, but running a database on a Linux system is as easy as typing SQLite and then enter, and now you can create a table and then query. This is the not sure how it works, the schema, but from select one and you get one, right? Select 1, 2, 3. You have 1 row, 3 columns, 1, 2, 3. So it's a good way of playing with it, toying with it, but it's a little bit out of scope for our what we're trying to do here. Okay. Quit. All right.
If I may just another bypass to try to end the query, you can just put
column. Oh, without double quotes, with double quotes. Oh yeah, interesting. So, but the quotes are the,
And it's not like the private space.
it works. Okay, it works on all engines. Okay, interesting. I didn't know about that one. So semi-column definitely worked. Okay. Yeah. So moving on to our next challenge. Whoops! I forgot to put the flag. I need my points. That's also a classic that happens in CTF. People are stressed and they forget. We see a lot. Okay, so communication in your team is really important. We see a lot of double submissions, which means if it's a 2-3 hour challenge, it means someone lost 3 hours, could have worked on something else, but worked on the same thing as the other. To organize, you can use Discord, Google Drive, you know, choose your or a Trello or Kanban, GitHub project, whatever. Yeah, there are means to collaborate in order to avoid losing time like that. Oh, we have a lot of solve. I'm impressed. You're familiar with this stuff. Okay, so self XSS is a weird one because it's totally fake. But so let's try. Okay, this looks like an SQL injection challenge. Let's try that. And this is not the SQL injection challenge. Okay, so why would you have immediately the reflex of XSS here? It's because you gave user input to the web application, and it throws you back your user input. So now the way of trying to see if you have an injection context is to try to write HTML. So contexts are super important in HTML, and basically if you can move from a HTML context into a script context, then you are basically running code in people's browsers, in this case yourself. But if you can trick the person, because the payload is in the bar address bar, so then it means that you can craft a URL that if you can trick someone to click on it, it will trigger the payload, it will run in his browser, and you will be the controller of that code, and then you will be able to make it exfiltrate secrets, which is the next challenge. But now we're just gonna XSS ourselves. Now, to validate if there is filtering or not, here I had decided to add B tags so that it will be bold. So does that work? Oh yes, it's bold. So it means that there is no HTML escaping. We are injecting HTML here. The payload that you will always see is a good old script alert1 payload. Which means that the browser will enter in scripting context. It will see JavaScript. It will execute it. So boom, I have a browser message saying 1, so it executed code, and the code is in the address. So it means that if I send this to anyone here, you will get a pop-up message 1. So congratulations, you XSS'd yourself, and here's the flag. Next up is Xss Larry. So can you Xss Larry the clicker? So basically here we're simulating someone who clicks on links, like everything you send him. So the goal is to steal something from his browser because he has cookies that we're interested in. Basically, if you steal the right cookie, you can impersonate me on Outlook or whatever, right? Whatever resource. So let's take a look. So whoops. So this is the page we want to steal from, and Larry is here. So basically, it's like sending an email with a link in it and hoping the person will click it. So it's just a simulation of that for CTF purposes. And I named him Larry. we want to steal a browser cookie for the CTF 101 domain, and if you want, so we don't know where Larry sits. All he needs is access to the internet to be, and we need something listening on the internet. Otherwise, we will not get, when we run code in his context, we will not get the ping to our context, to our system. So this is why I recommend you run PivotBox, but other people have their own machine online, and as long as it's reachable. And Larry has the same DNS resolver capabilities as we had for sysadmin service, which means that we can use sysadmin SSH, and it should work. And here it says, yeah, so since this is a shared system, we need to pick up each our own port, otherwise we will mess with each other. So let's connect there. I have the web server here. I'll pick a different port right away. I think it's just like that. Yeah, okay. So now I have a web server running on on all addresses on port 12345, which is reachable like that. Okay, we can try to see if Larry works. I think it should connect. I don't remember. And it's queuing the link. Will I get hits? Oh no, I did. Oh, no. That's not the. No. I need to put sysadmin SSH. Yeah, made a big mistake. So I need to use the host name that will be resolved as that system on that port. And so this is kind of the first test. So we know that we're getting hit by the bot. But now, this is why XSS is tricky. So what we need to do here is craft something in that web page, a URL that when someone else clicks on it, it will send the cookie to me, a third party here. But now, so to be able to build that, first we will try to access the content itself. So document point cookie. Do I have a cookie? Can I set a cookie? Il n'y a pas de parenthèse? Je sais pas, je pense. Il n'y a pas PHP? Whoops, ouais. True. This is the part I always rehearse usually, but I didn't today. So I might jump to my solution. So I have a Google Analytics cookie, luckily enough. And so I know that I am injecting, I can't run JavaScript. No, now how can I get these cookies sent to me? The classic way, I don't know. So these guys are actually working in the field. I'm a researcher, so I don't do XSS all the time, but they might have a very different payload than what I'll build with my notes. So I'm curious to hear about what how they'll come up with the solution. But let's start writing down the payload. Okay. So one easy way, and this is a bit odd, but if you basically put in an image, the browser will go and fetch that image. So usually this is one of the tricks that are used to make a browser reach a different resource. So we saw that the clicker will reach that. So if we do this, and then href with this, and then a.gif like this. So this locally will not be satisfying because my system doesn't know anything about sysadmin SSH. Whoops. Faut que je mette les single quotes. Non. Non, j'ai mis des double quotes, je pense. Exact. So, as I said, this wouldn't be satisfying, but ah ouais, quand je fais bien des erreurs. SRC, donc SRC, not href. Href is for a tags. SRC, but it will display a broken image anyway. But the where we're heading is like we're building small steps to see the whole solution. I have double quotes again, single quotes. Should bring that back to my notes. Okay. So do we have our image tag is what we're interested in. Ah, il est là. OK, c'est ça, il a fallu que ça time out. C'est bon. So the image is here. And if we look at the code, so the DOM has that node in it now. The DOM is the document object model, is the whole web page, if you want. So now we know that it worked. And now what we want to do is to give that to Larry. Okay, this is a complete URL that will fetch an image on a third-party resource, which is sysadmin SSH, results in a broken image for me, will result in a broken image for Larry as well. But the difference is that we will see that if it's working, we will see it in our logs here. That's weird ordering. Okay, message file not found. It means that we're onto something. Now, what we need to do is add the cookie in that command without, whoops, that's the link and the, oh, did we lose the, okay, it's there. Add the cookie without using double quotes. And I think this is where I always, I'm bad. So, ben, où tu peux assembler la string avant dans un script tag et utiliser la. T'injectes l'image. Ah, ouais. Ah, c'est bon, ça. Je pense que j'avais jamais vu celle-là. Okay, so when now there are thousands of ways you're injecting JavaScript. You can do it however you want. And now they're talking about the cleverest and smallest payload. The difficulty here is you can't use double quotes. So because of that, you have to like, you know, because you could assemble the string, but doing it without double quotes with the cookie, it's kind of difficult. So the solution that he's proposing, which is very clever, is that we're going to do this in a pure JavaScript payload. So window.location is a way in JavaScript to send the browser somewhere. So if Larry clicks on our link and we send Larry to our system where we have an HTTP server, and we can make the URL leads us to the string we're looking for, we will have the cookie and the flag. So window.location equals our SSH.service, which we can use single quotes. And then it's plus to concatenate. And then we're gonna do you know, just because we're fancy, you know, stolen equals, and then document dot cookie. URL encode the whole thing. Oh, just the cookie. What's the API? This. This is where you hit Google. Let's do it clean for them. JavaScript URI encoding. Yeah. Encode URI. Is that what you were looking for? Let's try. You know what? Let's do one without and one with, so we see the difference. Ah, true. Okay. I mean, I need to probably pack everything. Okay. So I want to jump out of the HTML context, jump in a script context. I want to send your browser to the. Did you try it on this one? Okay. Because I was not sure if if it would obey the location, redirect the bot I use. Okay, so we're gonna send the browser to that URL, and here we're saying the URL is something that doesn't exist with parameter document.cookie. So try it. To me, this is the hardest challenge of CTF 101 because I suck at web. Okay, oh no, I didn't do the good thing. So I made another mistake, classic mistake. I put it in the page visitor, but the page visitor visit links. This is not a link. So I need to do it on myself to get the link. Oh, I'm doing yeah, I'm kind of I'm redirecting myself here. Oh, 1 second. But this should work as well. Oh, I lost yeah, that's not the right payload. 1 second. No, I look now. Yay, I have it. So slow enough. All right, so I have basically the payload, and you could also URI encode the payload, and then you would get the thing is that slash are a special character, so you need to encode them so they become this is a angle bracket percentage 3C. The web is just a mess of encoding, and you always need to realize where you are and escape in the proper way. And with practice, this comes naturally. Like everything, no one bicycles on the first day. Yeah, so we have this here. Let's try. Oh, didn't get my usual Larry prompt. Okay, that's now it worked. Now if we whoops, that's here, and then oh yeah, so we're lucky here because we have the thing and it worked without the URI encoding. Let's try with the URI encoding. What will it change? But nothing was escaped. We yeah. But can we show them? Like if I put a bracket, I will break the. Well, it depends on you. So since Python quite I don't think it will mind first but I'm pretty sure it will work in Python, but okay. That's his idea because I'm gonna show you the payload I use. Usually, it's so complicated. I'm gonna put the final link here. Sans déception. Yeah, they're there to help if you want, and like XSS, there's a lot of XSS in CTF, and it's a very a difficult one to wrap your head around. So do not hesitate to ask for help. I thought I had my solution. Ah, here it is. Web XSS. Okay, so here this solution here, it uses a script tag to create an image element. So this is basically a way to avoid double quotes. So you can use single quotes everywhere because it's in JavaScript. And so you create the image element and you specify the source. And when you do so, it will basically go and fetch that image, and when it's trying to fetch that image, it will work. The complicated one I had was that I was trying to concatenate, and since you need the image and the source, you need two types of quotes. So that doesn't work. Mixing because the double quote don't pass. So I was using a char encoder. So this is like malware-like, but I was encoding everything and evaling the string from char code in order to build. They're laughing because they see how fucked up I am, and it worked. But it's like, yeah, I don't know. I've seen more malware than XSS in my life, clearly, and so this is the same thing, right? It will, and maybe it will it work? Nah, I'm using like 192. So I'm using hard-coded IPs that will fail. So, but the thing is that I built the payload and I encoded it in char code, and I'm using JavaScript to decode it from char code and then evaluating it, which means consider this string as JavaScript, which then runs the payload. And so this was my bypass to avoid the double quote. So when I said my solution was complicated, here you go. Okay. So with this, we exfiltrated the flag. So let's copy it and put it in. Submit. Now, a little break for us. Encoding. So again, this is comes often, and it's not. So why is it in CTF 101 since it's so easy? It's because it's always there, but it's not directly there. There are rarely points to be doing doing straight up base 64. But a good way to hide a flag so that you will not be able to find it by looking for flag is by encoding it in base 64. So this you kind of have to have the habit of seeing it often and knowing what to do quickly to look at it. And it's also a nice introduction to a very good CTF tool called CyberChef. So CyberChef is a web tool from GCHQ, and it's local. You're not sending anything to the spies in the UK. It runs in your browser. and it supports a ton of stuff. There's even one called Magic we can try, and Magic didn't. So Magic suggests base 85, but it used a depth of 3. We tried depth of 1. So Magic is not working for base intensive. Oh yeah, it's trying a lot of stuff. Maybe a bit too much, trying too hard. No, so basically base 64, the what gives it away for me is the presence of the equal sign at the end. So it's a padded format because it's not on 1 byte necessarily. And so and it always looks like this. So it's a reduced alphabet. It's meant to be safe to pass binary data, and you have it here, right? It's the second option. So from base 64, and then you will get the output in this field. Oh, there's a mistake. You should recognize basic encoding techniques just by looking at them. Congrats, because it looks like you just did. Here we go. Flag. Le CTF 101? Larry a trop cliqué. On va le repartir. Possible. Ouais. Je l'ai perdu. Je vais le power cycler. I put the URL on the Discord. Maybe that's the problem. They're probably more player than I anticipated. Je pourrais le resizer. Ouais, le delay pendant 2 heures. That's it. So we're gonna power cycle it, or not power cycle, but stop. So I'm gonna resize this to the point where I must not forget to resize it down, because it's gonna be $500 a month. I don't want to grow the disk. Can I do that? Yeah, CPU and RAM. Yeah, it's trying. It's trying. Maybe if I refresh. It's still powering up. Oh, it's down now. I don't like that error, that message. I'm not gonna resize now. Usually it's fast, but I'm not gonna take that risk. Turn on. So if anyone here you're unsure about your XSS payload, try to have it looked at by the guys here, the pros, because clearly we're exhausting resources. It could be other things, so I'm not blaming anyone. But yeah, Larry is a Node.js app that is spawned, so the whole JVM, so it can take some resources. It's the first time we're having issues like that, but we used to be. I never put it on Discord before, so if we're like 100%, then it might explain it.
But in the meantime, like the way that the XSS payload is kind of similar to what you were trying to do in the beginning, just an image that is invalid, and just on error, but the URL with the plus document cookie. I did need to do the.
Oh, yeah. Cool. So, but on error, but how do you on error you
Image source dot equal X, so it's always an error.
yeah
An error to fetch the URL plus document cookie. Because on the
ah
it's got compared to
yeah I know it executes code, but the you fetch the URL from where? From window location or no?
no, it's
Oh, you okay? Any URL plus document cookie, but this
the URL of the system, so you can reach it. Don't put any source, then it becomes always an error. Well, source equal X, but yeah.
But I understand, because this is gonna be JavaScript, but you need to build something that will query something. Do Ajax or
The same as Windows application.
okay?
So you don't need to write it. Then
So if on error you return a URL, the browser will boom go there. Okay, I didn't know that.
well, it's words.
Oui, ça je sais. Ouais. Ouais, moi je savais pas que ça faisait ça.
Maybe that's why I wrote it. I don't know.
Ouais, mais peut-être qu'il spin sur le. Okay, I think yeah, the sysadmin needs to be restarted, but besides that, we're good. Okay, everything is back up. Now let's complete our encoding one. And I have it. Okay, so we're back on track. Document 1. So there's a hidden flag in this document. It has 2 flags, and this is the easiest of the 2. So sometimes for a track, it's normal to have more than 1 flag in a single document, but you need to think, oh, maybe I didn't find the first one, so you need to think of submitting the other one. Let's do this forensic. Save. All right. Where is the flag? I know. It's a document. Things can be hidden away, right? So we're gonna search for flag. Is there a flag? Oh, look at that. There's something white with a mistake at the bottom. We can highlight it all, and then we can make it dark. My LibreOffice is broken. What's that? I don't even know where the colors are anymore. Ah, here it is. Okay, so if I put it, make it bigger. Okay, now color this. Oh, it's a flag. So that's a bad example, I know, but the concept of something hidden in plain sight is the lesson here. I've seen this in CTF, but I don't think we did something like this in NorthSec ever, and I don't think there's stuff like that at Hackfest. Is there?
I saw that in the real world. Like a Simon was trying to find something, so something like that. So it really happened. So it's not really that far fetched.
Okay, cool. Yeah, it is. In cryptography, they say it's the Kirchhoff's principle is that the power, the resistance of your cryptography must be in the key, not in the algorithm. This is what we've been doing for years in crypto. But prior to his statement, a lot of encryption was in the algorithm. Like you know, in the Roman days, they would tattoo a message on the head of someone and then wait for the hair to grow. And then when you receive the slave, you shave the head and you have the message, the secret message. So this doesn't respect Kirchhoff's principle, because if you know the algorithm, you're just gonna shave everyone and you're gonna find the secrets. So this is not against Kirchhoff's principle sound, because clearly if you know someone's gonna hide something like that by putting white on white, then you will find their secret. But so up and correct. And oh, we had many solves. We had 10 solves before I solved it. So congratulations. And all I did was search for flag. Now, this is the same as the challenge document 1, but there's a hidden lesson here again, and it's so where to find that, and this I had in a real CTF at Hackos, and when I was told the solution, I was really pissed off. So I remember for all my life the technique that was used. But so if we take the text, for example, and we copy and we paste it in Notepad. Notepad isn't rich, you know. Notepad is just whatever you had, right? And so, is it revealing something that we didn't expect? Let's not do Notepad. Let's do. Let's do local. So if we paste it in whatever text editor, so what we have is la sécurité informatique, capital F, E1, capital L, vast, capital A, champ, capital J. So from there, and then it's a dash, right? So from there, you could do F, L, A, J, dash, and then it's L, E, F, L, A, J, D, blah, blah, blah. Now, what we're gonna do here is another opportunity. So a classic DEF CON quals challenge would be to do something simple like that, but at a scale that you will not be able to solve it without programming. This is a very classical way that they operate, the people at DEF CON. So let's assume it's a super long flag and it cannot be done, and let's try to build a solution using the computer and do it quickly. Now we're gonna. So the first word with this is this one, and this is probably the last. Like sécurité informatique is okay. So let's just pick this string specifically. And then let's whip up the good old IPython console. So Python has a good REPL, so an interpreter that you can program interactively with. But IPython is better because it has syntax highlighting and it will autocomplete APIs. So I often work with something like that. Now you can, you know, like I am giving this as a string. And now what I want to do is, okay, let's get all the words. So I can try to do split on spaces. Now I have a list of words where the last letter is of interest. Okay. Now I can get into list continuation mode and try to do for C in. So now I am doing, I want a character, now I am iterating on a list. I can't, why I can't move? Okay. Now I am iterating in the list, okay? And if I do C for C in the split, I will get the words again. But now I have C, which is the each word, but I want the last character. How can I get the last character in Python? I think it's this. No, this is reverse. this. Yeah. Okay, so this is the last character. So this is what I want to use in my continuation. So here -1 and then the rest. So now, oh, now I have the last character of every word, but still in a list. And now I can join that list on and join it. The API is you need to use a string. So I'm doing an empty string join this list of empty empty not empty of the last character I'm interested in. Now clearly there's a problem because I have semicolon and commas. How can I make my one-liner even better? I can replace the characters. I can chain a replace with a comma to nothing. This does that get me further along? Okay, so I have a list. So I need to do that before the split because I want to work in string context, not in list context. And then split afterwards. Je comprends pas pourquoi ça marche plus. Okay. I have a key that does more. All right. Okay, I'm getting closer, but I still have the comma and the dots. So let's add 2 more replace. Again, I'm going a little bit fast here, but the lesson is like a little bit of scripting can go a long way. And this is the kind of scripting, by the way, that ChatGPT is really good at. So if you haven't played with it, you should, because otherwise we will be replaced by machines. But so we need to be smarter than the machines. We need to leverage them. So now we have something odd in there, but we have enough that we can probably figure it out. So we saw in the original string that there was one condition that didn't work properly. 1 sec. So we see here is there was no L, so this we skip this the T here, and then this is French, so it's le flag du fin observateur. We can probably figure the subset of French that is real from that here. So you know, again, in 5 minutes we whipped out a really quick scripting solution that we could scale. And this comes with practice. You know, you cannot necessarily succeed on the first run. But list continuations in Python is a very powerful construct that gets a lot done in a one-liner. And this is the opportunity of CTF code. You don't have to, you know, do ever anything again with it. It can be as obscure as you want, as long as you got the flag. Doesn't matter. It doesn't have to be maintainable. So \x A0, I think is new line or something like that got slided into here, or the A could have been from the good character anyway. So getting rid of that and getting rid of the lowercase t, submitting, and we got it. Network. Because all CTF have PCAPs. Pretty much true. So this is the Wireshark challenge. I love Wireshark. Now, but Wireshark can be really intimidating. So you have access to all the layers of the OSI model here, and it will highlight the bytes that you are interested in too. Sometimes what they will do is the challenges, they will drown you in data. So you'll have like large PCAPs, many things to look at. You won't know what to do necessarily. Here I went the minimalistic approach. again, an approach that by hand could be solvable relatively easily, but we will do a programmatic solution chaining C# and Python, because why not? Now, anyone has an idea or a suggestion on where could you hide flag using ping? So using ICMP, echo and reply, request and echo reply. So if we look at a regular, let's try to do a capture. Oops. Okay, so if I ping from my system on Google, this looks like this. So the layers of ping have echo, have a checksum, you have data. Data, interesting. So it seems to be, stuff, and then some characters, and then 0, 1, 2, 3, 4, 5, 6, 7. On Windows, it's another one that is very specific, right? It's ABCD or something. So basically, it looks like it doesn't matter what is in the data of a ping. And interestingly enough, it is symmetric. So the data of the reply and the data of the request is the same. And now I will slide in a little, classroom thing that I remember, but that is not important for anyone. The reason they were doing this is because before checksumming, there was corruption at the electrical level that will introduce changes in the data. And so by using ping, they could detect that kind of problem, because the response wouldn't be exactly the same as the request, and they could detect issues. But because of modern networking, this is just now a legacy, something left in there that is just useful to plug to sound smart. Now let's go back to our PCAP and look at the data portion. What we have is something, and then capital F, and the reply is the same. Now what's the next packet? Oh, capital L. What's the reply? Capital L. What's the next packet? Capital A. Starts to make sense, right? So if you want to do network extraction, data extraction at scale, you can use T#. T# will rely on specific, you basically give it attributes that of the data you're interested in too. By default, it's not interesting necessarily. Let's take a look. So by default, well, it's interesting as a for a sysadmin, but not for a CTF player. So it has like timestamp, IP addresses, and stuff like that. Now you can put it in a mode called the T fields. Is it T fields? Okay, capital T. Yeah, okay. So you can put it in a mode called fields that will tell it to go after the specific fields that you are interested into, which will by default, I believe, tab separated, so that's outputs nice on the terminal. So I put it in this mode, and now what I want to extract and look at is data. How do I know what's the name of that field in on a T# command line? I know by using this function here, prepare as a filter. So if I do this, it will put me as a filter on top a test, and I can see data equals something. Okay, I'm gonna give another example just to make it more obvious. Wireshark is a little bit small, right? Yeah, okay. So let's say I want to extract automatically the time to live. Okay, how would I do that? You'd go prepare as a filter selected, and you see ip.ttl is the way to extract that. So if we put ip.ttl in our T-Shark, here, let me just zoom back. Okay, ip.ttl, what will happen is that for each packet, I will have ip.ttl. Okay, so this is a very useful tip to know what are the fields names on the very detailed information that Wiresharks provide. Now, the one we're interested in is that data. So data, as we found earlier. Let's take a look at that. Data. Ah, it's cool. I would have expected to have it in as a string. So it's kind of disappointing. But Python to the rescue. How did I chain the T-shirt to the Python? Oh yeah, I remember. Okay, so another really cool trick with T-Shark. Oh, you know what? No, I'm gonna show you another tool, because the IPython console is cool, but it's not self-documenting. By that I mean that tomorrow you don't remember the IPython code you wrote to solve the challenge from the day before. How can you build something that is self-documenting so that you will remember, or be able to show to your friends or do a write-up for the CTF? So I'm a big fan of Jupyter notebooks. These are basically Python interpreters built in a web browser. Okay, so I use a lot for research. So now I will create a Python kernel, and one of the little known feature of the Jupyter notebook. So this is basically an IPython notebook. Like I can do, hello, and then print s. Okay, I run that, I get hello. I could do, 23 plus 47 and print that, and it will run. Okay, now what things that not a lot of people know is that if you prepend with a exclamation mark, it will execute a shell command. But you can also save that output in a variable, which means that you get, like here, you get a list with the content of the current folder. Okay, so now I saved the T-Shark command previously. What we're gonna have now is a list of packets with the content. The file doesn't exist, of course, because I am in that directory. So now I have a list of the packets of the data. I realized that it's all the same. So what I want is the last byte, but this is X encoded. So I need to extract the last 2 characters. So 1 character, 2 character is 1 byte in X. So yeah, CyberChef could make that clearer, I guess. So CyberChef 46 in from X means F, right? So we could solve it like that, pasting 1 at a time here. Where is my CyberChef there? Like we could copy and paste, but again, we're gonna do it the DEFCON large scale mode, so we're not gonna do that. But many people in CTF would have solved it like that, and there's no problem doing so. As long as you got the flag, as long as you have the job done, it's great. But we're gonna try to do it in a programmatic fashion. So I have this output list of packet. Now there is a copy, like the second packet I'm not interested in. So I want to drop 1 out of 2 from the list. if I had rehearsed, I would remember exactly the way to do it cleanly. I don't remember now, so we're gonna do the good old-fashioned Stack Overflow. Python list keep one out of two items. And the answer is complicated. That's not what I want. Keep only one out of the, like, drop. I have basically I have two Fs. I want only one F. Like, keep one out of two. Like, only the pairwise. Have something more elegant somewhere. Je l'ai pas. Pensais que je l'avais. Okay. No, there's a way to do that in the list context. One sec. Okay, I think it's. That's it. So yeah, so this will keep every one out of the two. It's very easy and fast, no loop required, but it's more harder to understand. And now, okay, so now I have a subset of my problem. Now I want to iterate over each list item and keep just the last two characters. So list continuations back to the rescue. C in packets. This will give me one. Now I want to grab the last two. And what does that give? This gives me what I'm interested in too. Now I want to cast this. This is hex. So I think this is one. No. I want char. Not char. String as no. Yeah. So now I'm close to the solution. So I am okay. So let's just bubble that back. We are dropping one out of every two entry because we had the ping and the reply. So we want only one because the data is exactly the same. Now for each in that list, so list continuation is always read outside in. For each in that list, I am keeping the last two characters. This is an X, so I'm turning it into an integer, but an X is base 16, so I need to tell it that it's base 16. Now I have an integer, and I'm turning that integer into a character. And now this is a list continuation, so it will create a list. And I use the trick I used before. So I join on an empty string, and I get flag network forensics expert. And when you think about it, so we're going to make the points before the server crash. That would be about its time to crash. We're good. Now, what is interesting here is look at how tight this is, right? It's basically, a two-liner to the flag. It's crazy when you think about all the powerful expressions that you can compact in a module that you will have your solution saved for you, self-documenting. So pcat flag. Here we go. All right. So if I convince you to use the notebook, what's that? Migration plan. I hope if I convinced you, I think it's a great tool to use for research or for CTF. And even for work, like you can program your work, replace yourself by a script. And okay, so reverse engineering. it's a crack me. Simple and safe to execute crack me. So why the asterisk is because you need to be careful with executables that are provided to you. Don't run them on your machine unless or use a VM for that, because you don't know who built it, and it could be evil, you know. So it's like at NorthSec we don't do that, but we've done ransomware, like fake ransomwares before, and you don't know. Maybe the challenge designer never intend for harm, but harm could be collateral damage. So the advice is always to use a VM, and not use not run it on your own computer. I've seen, like, an open CTF at DEF CON in Vegas. I've seen challenge designer put like destroy your home directory in flags because they were like, ah, that's cool. But I mean, it's this was 10 years ago. It's probably not out of fashion by today's standards, but you still have stuff like that on Stack Overflow, like or Reddit obfuscated commands that will destroy your machine. So you know you have to be careful. And CTF, they like to you know, mess with people. So I would be careful. Here, I'm gonna run it on my machine just because I'm too lazy, and I built it. Like, I created the code, source code, I compiled it myself. But so this is why I say you'll have to trust me on that. So we're gonna take a look at the easy one. I always either start static or dynamic. I think I want to start static with you guys. So static file analysis is you are looking at it without executing it. So you are leaving it like that, opening it. There's no chance of infection unless it breaks the software you're using to analyze it, which is very, very rare. I've never seen that before. Whereas dynamic analysis is you execute it oftentimes with a debugger, and you look at the state and you try to figure out what's going on. So it's difficult to design a good crack me, because when you think about it, this is an executable that has the flag in it. So it means that the job of the designer is to make it hard for you to get to that flag, but not too hard. So let's take a look at this one given that context. We're gonna use the Ghidra tool to do that. IDA Pro is too expensive for my taste, and so when Ghidra came out, I gradually stopped using IDA Pro. You can, because it's free and open source, but for static analysis, you could do it outside the VM. For dynamic, like we're not gonna execute it. But now Ghidra has a debugger, so you can execute it. So I would advise Ghidra inside the VM. Makes sense, a lot of sense. So I'm gonna use non-shared project because it's simpler. Where was my up? Here we go. Crack me, and then
Preparing some resources of energy management. There is a non-management website of .vault that has a lot of compilers, and now there is the inverse that is .vault, and it has a lot of decompilers, and a lot of companies that are creating compilers have the engine is available on this website, so you can upload like 2 megabyte up to 2 megabyte binary, and you can increase the results and compare with each compiler. So I advise you to try it and think about it.
Ouais. Non, mais je voulais trouver Godbolt pour partir vers Dogbolt. Ça, c'est, au lieu de God, c'est... I didn't know about that one. Ben ouais. So, and these online tools are really cool for CTF because you don't care about the content of the file. It's not like your company information. But be careful with like company files on services like that, because you don't pay, you're not paying, and you're sending them binaries. So if it's your products, I wouldn't use something like that. Well, let's try that. It will probably like solve the challenge like that, right? Yeah. So I'm not gonna use that for now. I'll put that aside. Okay. And Ghidra, every year I do the same crack me. Every year Ghidra is getting closer and closer to having it solved, like just looking at it. It might be the year that it will do that entirely. So Ghydra's UI is a bit confusing. So we create a project, but there's nothing there. You need to import is basically the first step. Oh, let me zoom. So everything starts with importing files, which is kind of the opposite way of IDA. And correct me. We're importing it. It detected that it's an ELF file, so a Linux executable. And then the dragon to chew on it. Yes, analyze it, please. There's a lot of options. Just analyze. Now it's finished, so it's a relatively small binary. And now we can take a look at the what happened. So executable have things that are exported by default, and you want to analyze the binary. Basically, you need to start somewhere, right? And some like hello world in C gets compiled on Linux, gets compiled down to I think it's a 16 or 4K executable. It's now what the C library and compilers adds is huge. And so even though start looks like the start of your code, it's actually like libc wrapper that does whatever. It's not interesting. So you need to find like what is your real entry point. And so you have a start main here and a main here symbol. So let's double click on that. Oh, now we're at something interesting. So we have a main, has variables, it prints performing intense computation. There's a function called dramatic. Sounds good. Then there's a compute. It prints the beginning of a flag. It raise. And then there's a loop doing a calculation and a put chart 10 in x in char is \n. So basically this is just a new line. So we have here something basically that prints a flag. So if we can have access to the lvar1 variable, we probably would have the flag. Now what is that raise call, right? It's weird. And since lvar1 is returned by compute, maybe we can know what's going on here. So what we have is stack variables, so local variables, and long things that look a lot like printable characters, but that Ghidra disappointingly doesn't show as printable character. So it's not, I'll still be doing that demo, because clearly they're not figuring out stack strings. It's okay. It makes my challenge last longer, a better lifespan. But so at this point, someone smart or experienced will be like, oh, how can I go back? Will be like, if I skip that raise, I will have the flag, because there's this is raising a signal. Signal can be caught or ignored by the operating system. So let's try running the binary and see how far we can get. So I'm using a hybrid approach now. New time I'm doing, first time I'm doing that. So to execute a file that you downloaded on Linux, you need to make it executable. It's not executable by default. So I'm adding all will have execution right. So this is shown here. Now, if I run the crack me, I have performing intense computation, and then a core dump. So flag and then segmentation fault. So this is clearly the signal. Now I'm going to wrap around and start it with GDB. So the GNU debugger, the default Linux debugger. And I have a GDB plugin. I strongly advise people to, if they're serious about doing exploit or crack knees, to use a GDB plugin. GDB by default is built for people who have source code, not built for reverse engineering or exploitation. So so a plugin will really help. The vanilla GDB that doesn't show you assembly, doesn't show you stack, doesn't show you anything. So it's just not helpful. So I use PwnDBG. I'm surprised that it works still. Not doing that often. And so I launched the program, but by default, since it could be malware, it will not run it. So I need to run it, I think. So I'm gonna do R, and then I have my performing intense computation. And I see what I see here is the state. Like this is what's not shown by default. So I have program received signal. So this tripped the debugger. So I still have control of the program, and it shows me the state of the registers, the disassembly of where I am. I am at this position in the executable, and this is inside the libc, I believe. And I have the state of the stack. So we see there is a string that we haven't seen before that is on the stack. And then there's the backtrace. So these are the calls. So start main, called something, called main, called raise, and then I'm here in raise. Now we can ignore a signal. The way to ignore a signal is by pressing continue, and we have the rest of the flag. So that's a crack me worth 1 point, right? So this is the easiest way to solve that challenge. You could also write the instruction pointer to try to skip the problematic code. Am I gonna try that? Are you good with GDB? I need to like specify content to a register. I haven't done this in a year. I'll try. YOLO. So run. We're gonna jam somewhere. So I mean, this is interesting for 101 because it puts you in the state of mind of how the machine works, and it gets you close to the metal and understanding how things happen. So why are we executing stuff? It's because an instruction pointer is incremented. So the instruction pointer is incremented by the computer, and it will fetch the next instruction. So juste quoi? Ouais, c'est quoi? C'est info? Non, c'est pas info. C'est set register. That's good. I'm gonna Google it, but I'm gonna do the theory first. So RIP is the instruction pointer. So this is somewhere in the CPU has this address, and this address is the code that is being executed. And so what we want to do, I went too far. What we want to do is to basically put ouais, mais là, je suis dans le raise. Fait qu'il faut que je fasse ça, mais dans le main. So. Ouais. Break main. Run. And now you can run instructions by instruction. So now I breakpoint into the main, so I'm in the main function, but we know that there's a lot of stuff that will happen before, and you can always use GDB side by side with the decompiler to figure out where you are. So we're gonna run this code up to a specific point that I don't see yet. So we could break on, we can do that. And then run up to that point. We can next. So by using next, you step over the call instead of stepping in the call. And I will, and then when you press enter, you basically reissue the last command. So I'm gonna try to step over the call. So the compute is a long function, so it took the time to execute and output the dots. Not compute, sorry, the dramatic. Now compute should be fast. And the raise is here. So we're gonna break on it. Star because it's an address. Continue. Okay, so now we're at the spot that we want to bypass. So what I'm gonna do, the instruction pointer you can see is exactly at this point. Now what I want to do is I want to set our IP to be the next thing. So it will never execute when we say continue, we'll never have the stack trace. JDB set RIP. You'd use the jump instruction to set it and continue. Okay. Can I do that? Ah, mais si je fais ça, bah oui. Mais ça, c'est offset du début du même. Si je fais ça. Ah, ok, ok, ok. So he's saying, like, you can put the address, but you can put a cute way that will be more easily rememberable. But you'll see when we will start looking at the hard variant why this is not something you can always afford to do. But it will be resolved symbolically like that. Or I need other fancy things. All right, so we jump at that. So we skip the stack, the signal, and we got the print. Now and it exited normally. So we skip the what was causing it to crash. So again, you know, many ways. We can also patch it. We could like nup. So the call to raise takes, I don't know, a couple of bytes. We can nup this, replace these bytes by 0x80, no 90, 0x90. And then when it will execute this, and then, or we should skip actually these two, because this is preparing the call. So we should skip these two, override these two by 0x90, and then this will just slide. So it will call, and then this will not exist anymore, and then it will move and jump and whatever. So there are many ways to approach a problem like that. Now, if we want to do it statically from Ghidra, we need to figure out what's going on here. Here we see that there is a SHA-1 call. So basically, this long ass string, which maybe backwards could work. No, it's confusing, Ghidra. But so this is basically a string that is being fed to a SHA-1 hash, and then so the flag is actually the SHA-1 of something. We cannot get to that something here. Maybe we could do it dynamically in GDB. We could stop at the right place where that string is assembled and figure out what it is. So we can run break on compute, continue. Are we on compute? Not necessarily. No. Next, continue. Where are we? Oh, compute. All right. So next. Okay, I skipped the first part. Okay, so array X. So the last instruction, this instruction here, put that X in the CPU and in the ARX register, and you can see that this is there is. So if I want to take a slow approach, I could start writing down the various content of that and putting it somewhere. I'm gonna do a new notebook. So there is, and then continue. Where is it? RDX. So the RDX is here. So no way with spaces. No way. Oh, it's here. There is no way. You are. Ah ouais, c'est vrai, vu que ça pousse, ça stack un peu. Ben non, mais je vais-tu le perdre? There is no way. There is no way you are ever go E. So it got combined, or it figures that this is just a long string. What does it look like? Okay, now it's gonna add it. There is no way you are ever going to figure. On va peut-être le perdre. On va le noter. Ah, avec la RSP. RSP plus 10. Plus. Whoops. Yeah. So, ouais, il n'est pas fini tout à fait, là. Mais, so before we do anything with the stack, so, and this will happen after the string length for sure. So we can do a next again. And now I think we have completed the string. So again, the string is added or pushed to the stack. So the stack is shown here. And what we're doing here is that we're saying, show me content of memory as a string. So /s means as a string. At $RSP is the value of a pointing by the RSP register. That is this address plus 10 in X. So how did I find the plus 10 in X is here. It's this here is 10X. So by doing so, now we have, there is no way you are ever going to figure this out. Okay, I have that string up. And now if we want to that we have the string, which was the hard part with Guidera. Now we have that string. We know it's doing a string length, allocating some memory, doing the SHA-1 of the string, and then returning. So what we're gonna do is the MD5 SHA-1 SHA-1 sum. Okay. So we're gonna do echo this pipe into SHA-1 sum. I could do it in Python, but it's gonna be longer. We're gonna do that instead. And self-documenting my solution, maybe lacking a couple words here and there. And now we're gonna try with submitting this with the flag beforehand. And it's incorrect. So, true. The echo does add a new line at the end of the string. Should have remembered that. And so because of the nature of hashing, this will output a very different executable. Not executable. This will generate a very different hash because I would like to verify it, but I'm gonna just forget. Cryptographic hash, the strength of a cryptographic hash is that to be entirely different based on a little variation of input. So this is what happened there, was missing, or Echo was adding a new line, and this code wasn't. And by removing it, we get a completely different hash. I'm gonna try it if that's our solution. And we got the flag. Now, let's put it in the decompiler.
So this is the one that we talked about IDA at the start of the reversing part. So the X-ray is the company that is making IDA compiler. So as you see,
can I show just this one?
Yeah.
Okay, okay.
The IDA compiler is a bit better in some ways. And he already figured the thing out.
It's the compute function is just code.
Yeah, I just read the code, and so it's one, and that's how I did it personally. And another tool that could have been very useful is the plot. Is
wait.
Better version of string with made by class system. No, I don't know.
No, CrowdStrike. No, Mandiant.
And so plot basically is like string, but it also shows the fact strings and stuff like that. So you can have run the binary inside of a plot, and it's related with the fact string, and you could have given the flag. I think.
Let's try. I have it installed. I've never used it. I saw someone at an event. I actually know one of the guy who worked on it, but well. No, mais le tool online, the web page. So, okay, well, that's a very powerful thing that I will remember for sure. And so now one thing, so this, unfortunately, no matter how hard it looked like, this was the easy mode because the binary was not stripped. So all of the strings like main and compute and everything that was a name of a function is there because it helps debugger understand the binary program. But production binaries are most often stripped because it makes the binary smaller. Then we'll take a look at what it looks like. It's a different beast. I need to download it first. Four, yeah. So the difference is like we go, like if we look at the export, let me zoom in. if we look at the exports, they are very different than earlier, right? We have two functions that were identified, standard out, which apparently is an export. Not sure why. Functions, we have the functions are like all unnamed functions, but disassembly or decompiling tools are meant for, are built for that, for you to rename. So now I'm gonna try to find the main. Not sure. Okay, so this is the main, right? libc start main, and this is still a named function because it's part of the libc, and the tool knows that it's that because of the way the elf is structured and loading. But now this is here our real main. And so the practice of reverse engineering is basically taking this, saying rename function, writing main, and you can have your own naming convention, like when you're unsure, you underscore or z or maybe or whatever, and you try to go as fast as you can to confirm if it's clean or not. But now look at this here, like the printf is part of the C library API, so it's there clean. But our dramatic, our compute, everything has been like hidden away. So if we look at this, it's still, you know, doing the same SHA-1 thing, but now there are no addresses that can be used to figure out, not addresses, sorry, names that can be used to figure out. And when statically, you know, you give it names and you move around, it's not too bad because it will remember the name that you've given to stuff. But then when you switch to your decompiler, your debugger, things are a little bit harder because I need to make it executable. Up. So things are a little bit harder because you cannot do break main. You don't have a main. So you need to figure out where is the entry point. This is don't remember. GDB finding entry point. Info file. Info file. So now you have entry point is there. So the I think the entry point will always be, yeah, if I run, I will be in the entry point. No, it ran. So it ran up to the crash in this case. So if you want, if it would be malware, this would have been a mistake. Let's try again and do a breakpoint on, whoops. There are no symbols, so I can't disass main anymore, but I can disass the entry point. So info file can disass this, but this is why I like, whoops, no. So this is why I like PwnDBG or other modules like that, is I would break on the address and then I would run until the address, and then I would have something to then move and walk around. But this is not our main yet, and it's still not unclear. And I think this is kernel address space. Maybe not. Don't quote me on that. I would next. Whoops. Step instructions. Continue. I don't know what I'm doing. I don't know. I will try to, I guess, break elsewhere. Anyway, the previous way to solve it still works no matter if debugging symbols exist or not. And this was the only difference between the easy and the hard. Is not nothing in the code is different. It's just that I stripped the symbols from the binary, which by definition makes it harder. But most reverse engineering or crack me or pwn challenges will be built like that to make it harder for you. But then you still have, as you walk around, you still have some strings to help you figure out what's happening. And there are tools, I believe, that synchronizes the whatever you do in Ghidra, you will have in GDB. Same with IDA. So if you rename a function there, you will have it in GDB. These are complicated to set up. So if you do some basically, people working a lot on reverse engineering or crack me's or exploitation challenges should spend time oiling their tool chain to make sure that stuff like this is workable and possible. And there are a lot of good tutorials online. And pwn DBG, this specific GDB plugin does have a bridge for IDA that should help you be faster at doing this.
By the way, the UDD is for Linux binary, but if you encounter Windows binary, you could use X64 UDD on Windows to be different computer.
Yeah, X64. Yeah, people used OllyDBG a lot before, but X64 since 6 years has been a solid alternative. But sometimes Ollie, there's something about Ollie, like for Packers, for example, that Ollie just never breaks. But I think X64 is really reliable and used by the industry more and more. There's also WinDBG. It's harder to use. It's kind of like GDB, but it is the one provided by Microsoft to debug their own stuff, including kernel code. So but it's a lot less user friendly than X64 DBG. So again, make sure you try both. And I know like these references might be hard to remember, but I'm gonna do a deal with you here. Everyone's still here or on the stream. If you come and see me during the CTF, I will be there the whole weekend. And you're like, hey, what's the name of the tool? I will happily like give it to you again. Like this is not cheating. This is just like I told you. It's just that I didn't have slides, so you don't have takeaways except just 3 hours of me ranting. So I'll happily give it back and give the good one. Oh, give me the context of what you're trying to do. I'll give you the pointers to the tools. And you can do that with the guys here as well. This will not be considered cheating. I think we're on YouTube. So, but so for the weekend, we might have a YouTube, but it will be a raw, unedited. You have to like go through it and find the parts you're interested in. That's it for me. Or is it? How long? How much time? 36 minutes. I don't think I want to get into the exploitation. Do you want me to do the exploitation? It's a bonus. Okay, I'll do it. I say here no answer or explanation. It's because this is like medieval level OSCP from 10 years ago exploit. It's a stack smashing. It's not modern at all because since then a lot have changed to prevent bugs like this in compilers, in CPUs and all that. So this is kind of as fake as it can be. But let's look at it. I have 36 minutes and I'm rusty. Okay, exploit. So most exploitation challenge starts with a service. It's usually text-based because it's very minimalistic, and the goal is just to write to memory and then have the computer go in that memory and execute what's in it. So here we have a serial number checker. We're gonna do a test. So this, sorry, wrong serial number. Then we're gonna do a classic, and then I'm not having a wrong serial number. I crashed it. So there's something broken here. I need to figure out what it is. We get the service again, and this is because we run it in a mode where it will restart on the next connection. So then you can hunt for the right length where you crash it. So you see, like, between these two lengths, I'm crashing it. Now, the source code is provided, and the instructions to compile it as well. So let's download the source code. So we have a compute function, we have a validate function, there is a session, enter your serial number we receive from the network. There's a success and then a confirmation number or wrong serial number. Runs on 1, 2, 3, 4, 5. Server is ready and it's forking. So this here. Okay. So it says on what it runs. This is important for to have reliable addressing. This is one reason why Linux is harder to exploit than Windows. It's because it's more, when you do exploitation, you need to have a great understanding of the state of the memory. And on Windows, since it's all pre-compiled and the same thing, every Windows version is like the same. Whereas on Linux, you need like the exact one because there's new versions every 6 months or so. So this information is kind of valuable if you want to exploit it quickly. Now, in order to do local testing, we will need to be able to compile it. So create a fake service file. Do I run? Is there still a Docker for? Let me check 1 sec. Do I have? Le Docker, ouais, mais je me demande si ça me prend pas un vagrant. Parce que Ah, me semble que j'avais pas réussi. Moi, tu penses? Là, je vais-tu avoir accès aux fichiers locaux? Ouais. Juste quoi? Juste point? Ah, ouais, ouais, ouais. Slash quoi, host? Slash ou deux points? Puis, bash. Oups. Non, mais je starte pas mon Docker par défaut. Je m'en sers pas tout le temps. Puis des fois, à un moment donné, je m'étais rendu compte que je roulais des WordPress exposés sur Internet. J'étais comme, calice. Excusez pour les gens sur le stream. Unable to find. Oh, it's still there. I thought that because if you look at the here, like they don't list 1404 anymore. C'est pour ça que je pensais qu'il aurait pu. They don't list the old images. Ben, j'ai besoin d'un compiler. So we're spinning the exact version of that operating system. We are installing stuff to compile. Ouais. Oh yeah, good memory. Then they're probably pointing to a slow archive that still works. Okay, so we're installing stuff to be able to compile. Then our instruction. So we need to put this in services.h. Otherwise, it won't compile. From here. So this is out of the Docker image. Ouais, ça c'est bon. And this is inside the Docker image. Then compile without. So we need to put no stack protector because the compiler has that protection built in now. This is why I was saying it's a very old technique but to show how to smash that stack. And I'm missing stuff. Kernel image ou ah ouais, ok. Ah non, non, mais ça, c'est pour faire 3264. Ah ouais, le Docker. Oui, oui, il va prendre la même architecture. Good point. Good point. I'm glad I have helpers. Because sometimes you lose hours on stuff like this. So, okay, I have service. Can run it. Ben, je vais le mapper, le port. Parce que si. Ah, mais quoi? Vu que ça fait le même binaire. Ah, mon hostname il a changé. Okay, so again, now we're giving it network access, and now do I have this? I'm gonna install that as well. Terminal multiplexer. If I want to debug it, it's gonna be useful. So service. This is usually when you have a 32-bit to 64-bit problem. Quoi? Tu penses que je l'ai perdu? Oui, oui, non, mais je comprends, mais je suis un peu traumatisé. Ça veut dire, si je ferme le container, je perds tout. C'est chier. Ouais. Ouais, mais là, c'est. Ouais, ok. J'espère que j'aurai besoin de le recompiler. Ça... Non, 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 c'est apt update. I told you I didn't want to do this, by the way. So you're here, you're stuck with me. Ça part, ça part. Bon. We can look at the source code in the meantime. Whoops. So this is, I think, where the magic happens. A pointer and a copy to a buffer of a limited length. This is terminated, so it should be good. This one is not. So here is the bug is here. Okay, server runs. Now, can I connect to it? Yay. Okay. So what's cool about that is that we can debug it. Of course. Ouais, t'avais raison, là, vu que c'est un binaire, ça aurait marché. Là. Linux et sa compatibilité légendaire. Ah, Chris. Ah, fuck off. Non, 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 c'est juste trop compliqué à installer. Attends, on va le rouler là, voir. Bon, ça marche. OK, on va le faire dans. So the container is meant to compile the binary. It will work on the system but this is why you need a vagrant. This is gonna be 64-bit addressing, and the bug is not. I think the bug is 32-bit only. I think this is why I need a vagrant. Ouais, mais on l'a compilé out. OK. Okay, so this is I used to teach this like 10 years ago. And this is what I was using to explain the solution. So one of the first complexity is that there's a fork call. By default, GDB will not follow the fork, the child. It will stick on the parent. So we need to get rid of work around that. Now we could add symbols as well with GGDB3, and then follow fork mode for child. And with the symbols, we can break on sessions. Now, yes. You need to compile it on a specific on Ubuntu 14.04. Otherwise, no. Or it might, but you'll have it like my answer, because my answer is just one string and boom, it blows up, right? So the flag is not, even if you compile it, the flag is on the server. So whatever you'll find locally to exploit will not work on the server because it's going to be a different thing, which means a different memory address. Same principle, but you won't grab the flag. So this is why you need to mimic the target so that it will work. So so here the flow, as I was saying, the second string copy here, it copies to a buffer of 8, but the source can be up to 18. So you will overwrite, and since value 2 is below value 1, you overwrite. Since buffer is below the integer values, you override the memory going upwards, which means that you can smash value 1 and value 2 at this place. So you have effect on value 1, even if you are after. So the way to solve this challenge is to use the buffer overflow to make sure that you will overwrite value 1 with something that you know will match value 2. And value 2, you are in control of it because it's whatever your buffer is and this out of the compute function. So in the debugger, if you send like we often see sequences of A's, but it's more useful to use different characters because then you know you're at this position or that position. There are tools in PwnDBG that will, or Radare has tools like that as well that generates the sequence of a length that you specify. But here we've done it by hand. I've done it by hand. I don't recall what they are. So when we look at the string copy, this is what the memory looks like when you have that. So you can see 41, 42, 43, 44, 45, 46, 47, 48. And if you look at the buffer, this is the content of the buffer. Then value 1 is this, value 2 is this. Now, after you run value 1, that's the state of the buffer. Man, I don't remember any of this. And value 2 is this. So they are very different. Like and it changed drastically after the overwrite. So buffer will receive SN plus 9. So here SN plus 9 will be what's sent to buffer. What's complicated is that there are infinite number of solutions because you need to have two things. That one thing that you control that you send, it will be cut in two, ran some compute, and it will be compared to one another. But some of it you use to overwrite one of the values. So you need to align them. So the solution we are narrowing into is one of the many solutions that could be. So if we smash value 1, we can make it so to pass the test, validate will be true. So now we did like fake tests if you want. So you know, value 2 is this, value 1 is this. So we're not quite there. And also you have to avoid non-printable characters. So try different input, iterate on what you send until everything that you need, that value 2 is printable characters, so that you will be able to overwrite value 1 with printable characters.
You need to change your printable characters because it does use p50 on the first to the other is p50 and it stops when there is a non-printable value.
Doesn't it stop only on \0? Oh, okay. So there, yeah, there are a handful of them that will stop the copy. So basically the A, B, C, D, E, F, G payload, you know, got us there, but we cannot progress with it because this will generate after it goes through compute. It will generate non-printable characters, which means that it's not a good payload for the exploitation. Now, if we send many A's, you will get into a mode where everything is ASCII. So value 2, everything is ASCII. Now that we control value 2, now that we know value 2, everything is ASCII, we need to just adjust our payload so that value 1 will match value 2. And we can do that locally because we have access to the, we can debug the program. And again, I mean, this is like the shittiest. I did it that way at university. This is how I write it up. And with like, this was before Anger. I'm sure in Anger, someone who knows how this thing works will like solve this like this. Anger just basically, you know, find that does all possibilities and finds the one that narrowed down to the state that you want to be in. It's just I've never used Anger except taking in a workshop. Never used it after. So I would need more work. This is why it was a bonus. Like I need to prepare more in order to teach it better, but you'll still have the solution. But so in my testing, I arrive at a payload that I thought would work by doing the math, but there was an issue, so I was obtaining something slightly different. But if you invert the 2 value and you add the A, then I arrive at a payload that worked, and this is basically the exploit for that challenge. It will get it in the state that you need to be in. So I can show you, but I mean, the better way would be to debug it, but the error I'm getting, I'm not convinced that by running it on a 64-bit system, this solution will work, but we can try. Ouais, mais c'est ça, mais tu sais, si je voulais faire un payload qui marche local, là, il ne marchera pas sur l'autre. Ouais, ça va marcher. Je l'ai déjà fait. No, but I want to try to crash. I don't want to do the solution yet. I have 11 minutes left. You're right. You are correct, sir. Okay, let's try to run it. So now I've shown you the solution. We're gonna wait until the end for the money shot. But so now I'm gonna try it in the 64-bit environment. We'll see what it looks like. We'll try to go, but I'm not convinced that we're gonna progress much in 10 minutes. But what Vincent was saying is that I need to do all of the set, follow, fork mode, whatever, to be able to put it in the right state, that where I will follow the child, and then I could run it, but not sure what it will look like without symbols. Then run. Okay, so it's dying, and can I connect again? Yes, okay. But I don't have any breakpoint. Is do I need to use a 32-bit GDB? Si je l'ai? Ben oui, ben non, mais je vais l'avoir, là. Je vais l'avoir, mais parce que j'ai copié de ma solution, là. Non, mais là, ils m'ont demandé de faire le bonus, là. Genre, puis j'étais comme, je suis pas prêt. J'ai pas dit ça, j'ai dit oui, pas de problème. C'est ça. Ah, Steam, wow, ça va m'aider. Ouais, c'est peut-être M32. Attends une minute, ouais. Non, ok. Google. GDB 32-bit mode. Ça, je les ai. Ah. Ok, on va y aller avec GDB mitaine. Ah, là, j'ai tout pour compiler. Let's compile with this, but whoops. No, no. Whoops, no. Ça, puis ça. Ah, je pourrais breaker direct à la bonne place. OK. Ah. Tu lis les messages plus vite que moi. Error disabling address space randomization operation not permitted. Eh ben. Ah, faudrait que je le roule privilege? Non, non, mais le Docker, moins privilege. Sûrement. Non, mais même s'il ne randomise pas, c'est pas grave parce que je ne dépasse pas. C'est un local smash stack. Un local smash, ça devrait marcher. C'est GDB. Moi, je pense que c'est GDB. Parce que GDB doit essayer de dire disable ça. Puis. Ah, il est où le process là, qui run? Attends, non, netstat, ANP. Chris, c'est où qui run? OK. Ah, c'était peut-être lui. Le C-bind à chaque. OK. Bon. Ah, ouais, Caroline. Peut-être. Ouais, attends, on va le copier. Ouais, là, ça serait du trip, le debug, là. Je sais plus. Il reste 3 minutes. Let's space the payload. OK. So, the service is running here. And ça marche. Stack corruption for the win. So, I mean, I wish I had something better to show you, but what happens is that we, again, like from the source code here, we are providing a buffer that is too large here, and the first string copy is fine because it's there is a null pointer that a null byte that is injected in the original char buffer buffer that will make the string copy end after a fixed amount of characters. That is the size of the buffer. Then value 1 is computed. We have no control over any of this besides the regular first part of the serial number. Now, the second string copy arrives and to a new buffer, like we're kind of reusing one variable here, but then we copy from the 9th position where nothing was made to ensure the length of the thing besides the like it's accepting between this and that. So then this copy will overwrite content and it will overwrite up. So the stack is buff value 2 value 1 or buff value 1 value 2. But so you are overwriting content on the memory and then value 2 is computed. So no, yes, you override value 2 and value 1, but value 2 is then rewritten. So then you have to make sure that whatever is rewritten here and whatever you overflow there is equal, and and must be all printable characters. And the way to achieve this is when you have a lot of A's through the validate function, the compute function, sorry, will create this value. I think this value. And yeah, so yeah, this one was extracted from a run, and so this is when we figured that we need to put this at the end, but it turns out that it was not long enough or whatever. So I like, and when looking at it, you realize that the two characters are inverted here. So you flip them in the right order, and then you pad by 2 other A's, and then you get the answer. And if we do the smash stack eruption for the win, yay! I completely cheated. Oh, 2 solves. Someone from here. You figured it out, or you copied? Because I was gonna say next year you're here. Okay, well, thank you so much, everyone. It's been quite a ride, and now I must sleep. Have a merci. I hope you have a great CTF, and if you have questions, do not hesitate to come and see all of us. We're here to learn. Ah, c'est vrai?